I'm an ex-Big Four consultant with over 10 years of experience at Toileted, and today I want to teach you the basics of a Python library I used a lot in my data projects to do ETL, data cleansing, and report automation. It's called Pandas, and it's like a smarter, musclier, and cuter version of Excel VBA and SQL. You can use Pandas to query data like you would with SQL, and you can use it for data analysis like you would in Excel and VBA, like doing sorts, filters, remove duplicates, and formulas. It's an amazing tool to learn, and this video is a quick crash course on the basics of Pandas, where you'll learn how to install Python, Pandas, and our code editor. You'll learn how to import data, add new columns, convert data types, sort data, remove duplicates, do a left join, replace values, use if statements, and finally export our data to CSV. The dataset we'll be using for this crash course is made up of driver license data. On the left, we have the contact details of a driver in a CSV file, and on the right, we have their license details in another CSV file. As a data analyst, the requirements you've been given are to add a column for full name, so that's concatenating first and last name, remove the time from birth date, so it only has the date only without these zeros, join the driver and license files using a left join, replace the 1 and 2 values here with no and yes, determine if a license status is valid, if test passed is yes and points is less than 12, and then split and export the data into two CSV files, one with valid statuses only, and the other with invalid statuses. If you love the sound of all this, then let's jump into it, where we'll start with installing Python, Pandas, and our code editor. Let's start by installing Python, so open up your browser and go to python.org. Hover over the download section and just download the one for your operating system. The current version is 3.11.3, but by the time you watch this video, there's a good chance that there'll be a different version. Click on the add python.exe to path, click customize installation, make sure all these are ticked, press next, tick all these options as well, and update the installation location to just C drive Python 311 or whatever your version is. Click next. This might take a few minutes, but I'll just fast forward to completion. All right, with Python installed, let's check that we've actually installed it properly by opening our command prompt. So that's just window key, then type in cmd and you'll get this. And then you'll type in Python space --version. And you should get the same version that you just downloaded. The next thing to do is to install our code editor, which is Jupyter Notebook, and to install the Pandas library. So to install our code editor, Jupyter Notebook, we'll type in pip install notebook. I think pip stands for package installer for Python, and that's just the software it uses to install like Python libraries, add-ons, extensions, etc. I've already got mine installed, so that was really quick. But yours might take a few minutes. And then the next thing to install is pip install pandas. That's our data analytics library. Again, I've already got it installed, but this step will take a few minutes. Now that you've got everything installed, let's launch our code editor. But we want to launch our code editor in the directory or the drive where we've stored our course files. So mine's stored in D drive. So I want to launch the code editor from D drive. And then to launch the actual code editor, we type in py space -m space notebook. A new browser will open, which kind of looks like Windows Explorer. It's like, here's your folder setup. And I've stored my course files in AP Data Analyst Crash Course, and you'll see the two files here. What you'll do is create a new Python 3 notebook. And when you do that, and you open up Windows Explorer, you'll see a new file has been created, untitled.ipynb. I think that stands for IPython Notebook. And then you can update the file name by clicking on the title at the top. And maybe we'll just call this Data Analyst Crash Course. And when you do that, it gets updated in Windows as well. To check that we've installed the Pandas library correctly, we'll type in import pandas at the top and press Control Enter. We didn't get any errors, so it looks like everything was installed correctly. Just to give you a quick overview of the Jupyter Notebook code editor, this part here is called a cell, and it's where we'll be writing all our code. If you want to write all your code within the one cell, like you normally would with any other text editor. You can do that, and you can press run at the top there to run the code, and that creates a new line or a new cell underneath. If you want to execute your code and not go to the next line, you can press Control Enter, and that's what we'll be using for pretty much this entire video. If you want to execute your code line by line or bit by bit, you can put it into the next cell as well. So when you run that and run this, it gives you a bit more modularity. You'll notice that when we're running our code, our bar here goes green, but when we're not running our code, so when we press escape, the bar goes blue. When you're in blue, it's called command mode, and when you're in green, you're in edit mode. When you go into blue mode, command mode, you can use keyboard shortcuts like A to create new cells above the current location that you're in, or you can press X to delete the current cell you're in, or press B to create new cells below the current place you're in. When you're in edit mode, you're obviously just typing in those actual letters. Press escape to go back into command mode, and let's just delete all these cells with X. So we're back to the start. So we'll do import pandas, and to give it an alias or a shorter name, we can go as PD. So we'll be referring to pandas as PD moving forward. Okay, so the first thing to do with pandas is to import our CSV files. And to do that, what we'll do is create a new data frame, and we'll make that equal PD. So we want to call a pandas function here, and the function to call is read_CSV, and the parameter that we want to pass into it with the open close bracket and single quote is our driver and license file. Now, since our IPython notebook is in the same directory as our CSV files, we don't need to type in the full directory of our file. We don't need to do this because this file is already in the same folder as these two. So all we really have to do is just pass in the file name, press Control Enter, and it looks like nothing happened here, like the number increased to indicate that's like the 10th cell that's been executed. But we have to display the data frame, much like how we have to print our code. So we show the data frame with just by typing out the variable name, and there you go, that's our driver file there. And then to import the license file, let's create a second data frame called df2 equals pd.read_csv, open bracket, single quote, license.csv, and we'll display that too. There, cool. That looks like everything's working fine. If you're wondering why our first data frame isn't displaying, it's because Python only shows the output of the last line, which is this one here. If you want to show both, what we can do is cut this, press escape, press B to create a new cell underneath, paste our second data frame in here, and there we go. We've got our two data frames displaying. Okay, with our data imported, let's start doing some, data transformation and cleansing on the data. So what I like to do is just create a few new cells and then type in some comments about like what transformation we have to do, right? So the business requirements we've been given were to add a full name. If you're new to Python, the hash is essentially a comment in Python. So when you run this code, Python knows to ignore any line that has a hash in it. So this is a good way of like annotating and documenting our code. So the first requirement was to add a full name. The second one was to remove time from birth date. You'll notice, there was the midnight time there that we want to get rid of. The next thing was to sort by first name and last name. We need to remove duplicate from driver ID. We also need to join the driver CSV and license CSV files together. We need to replace the test passed values of 1 and 2 with no and yes. We have to add a license status column based on a certain set of conditions from test passed and points. And then finally, we'll export the license statuses into a separate CSV where they're valid. So export valid statuses to CSV and export the records with the invalid statuses to another CSV. Awesome, they're our business requirements, so let's start typing the code out for this. So the first thing we want to do here for add full name is to add a new column to our driver data frame. Let's just remove this for now so it's easier to read. So we're going to add a new column, and we do that by stating the data frame column name, which is df square bracket single quote, and we'll call this column full name, and we'll make it equal the data frame column of first name plus the data frame column of the last name. We'll probably need to add a space in between these two values as well. And then we'll display the data frame by typing out the variable name. And there you go, we've got the full name as a new column in the data frame. Easy peasy. Moving on to the next requirement, remove time from birth date. By the way, if it's getting kind of messy to see, all the data frames and all the results of everything you've outputted, what you can do is type in df.head, open and close bracket, and that'll show you the first 5 records of the data frame. If you want to see the last 5, you can type in tail. And if you just want to see like a specific number of records, like the first 3 records, you can put in a number in between the brackets. So to remove time from birth date, data conversion, I guess in any language can be a bit of a pain, and it's no exception in Pandas data frames, but specifically for updating a date time to date, what we'll do is let's just analyze the data types of our data frame by typing in df.dtypes, and we can see driver ID is an integer, and everything else is basically an object or a string data type. And for birth date, we want to convert this to a date or a date time. So what we'll do is grab the df birth date column, and we'll make that equal to a date time conversion. So we'll call the pandas to_datetime function, and we just have to pass in the column of data that we want to convert, which will be birth date here. So you can see we're updating the column name by making it equal itself. And when we run this, we should get that converted. But instead we've got an error. And if we look at the error, it says the time data that we've provided it doesn't match the format that it's expecting. So we've provided day, month, and year, but it's expecting month, day, year. To fix that, all we have to do is to pass in a second parameter called day first and make that equal true. And when we run that, everything looks correct. The birth date has been updated to a date time. And when we display the data frame, we can see the time has been removed from birth date, which is good. All right, the next thing is to sort by first name and last name. So we'll call the data frame .sort_values, open and close bracket. And we just have to provide the column names that we want to sort by. So that's going to be by equals square bracket, and in single quotes, we'll type in the column names that we want, which will be first name and last name. So if we run that with Control Enter, we'll see first name and last name. Yep, the data frame's been sorted alphabetically A to Z. If you want it sorted Z to A, you can pass in a second parameter called ascending. And if you want it Z to A, you pass in false. And if you want it ascending, or by default, it's true anyway. Now, a funny thing is, when you display the data frame again, the sort looks like it's been removed. And the reason that is because when you call most Pandas functions, it actually doesn't update the data frame for you. It just shows you a version of the data frame with the transformation that you've applied. I guess it's kind of like a failsafe to make sure that you don't accidentally overwrite any important information in your data frame. But if you want to set or make the updates immediately to that data frame, make the data frame equal itself. And that's the easiest way out of it. So it's permanently made those changes to the df variable now because we've made it equal itself. All right, next is removing duplicates from driver ID. Now, if you look at the data here, you'll notice that Catherine Hillard appears 3 times here. This one looks like an absolute duplicate because, all the values are exactly the same. But this third record here, this could be a completely different Catherine Hillard. Just a coincidence they share the same name because they do have a different driver ID and a different date of birth. So it's most likely a different person. But I'm going to show you 2 ways of removing duplicates. One, where you remove the identical records, and 2, where you can remove by a subset of the data, so by like first name and last name. So to remove duplicates where you get identical records, it's just df.drop_duplicates, open close bracket. And when you run that, you'll see that the duplicate Catherine Hillard, this one here, has been removed from the data frame. If you want to remove that second Catherine Hillard, all you have to do is pass in a subset parameter equals square bracket single quote, and we want by first name, comma, last name. And when we do that, we can see that we've only got 1 Catherine Hillard left instead of 2. And again, if we show the data frame, all Catherines are returned back to the data frame because again, we didn't make the data frame equal itself. This just showed us a version of the data frame with the function applied. So we'll make it equal itself to make the changes permanent. We don't want this subset one. We just want to drop all duplicates where they're identical. Let's comment this one out. It's good to keep this for future reference, just for the syntax, but this is the one we want. Cool, 2 Catherine Hillards. The next is to join the driver CSV and license CSV files. So if you come from an SQL background, this is basically your left join, inner join, and right join. Instead of joins, they're called merges in the data frame. So obviously, you've got a set of data here and a set of data there. The inner join is whatever intersects in between the two, and left join is only the data here, right join only shows the data from here. And obviously we have to find like a unique key or a unique value to join the 2 data sets on, which will be driver ID. So to join or merge the data sets, we use the Pandas function called merge, and we want to merge data frame 1, which will be like the left table, and data frame 2, which will be the right table. We specify the key on the left table with left on equals, and that's just driver ID. The right key will be driver ID again as well. And how we're going to join it will either be by inner, left, or right join. So let's just have a look at what inner looks like. I believe we have 20 records in here. So if I just go length of data frame, there's 20 records. But in here, we've only got 19, 0 to 18, right? We've only got 19 records here. So what's happened is, I think if we go back to the start, we can see that and I think it's Catherine Hillard, we have a license for Catherine Hillard here, but we don't have a license for this Catherine Hillard there. So the inner join finds whatever driver IDs are a match and then displays it in a new data frame. Because it couldn't find 99999 in this table, it just didn't return the result. So you only use inner join where both files have matching IDs. You can use a left join to display everything that was in the first data frame and the additional details of data frame 2. So you can see that Catherine Hillard was added back into the data frame, but she just doesn't have any record or data for license type, test, pass, and points. Nan is basically null, or I think this stands for not a number, but it's basically a null. And then lastly, if you do a right join, the 99999 record is removed again. For this instance, I think we just want the left join because we want to keep all the driver contact details and the additional license details as well. We'll make this equal itself so that the changes are permanent. All right, the next thing we have to do is replace test passed values 1 and 2 with no and yes. So this one's going to be pretty straightforward. Let's grab the database column name. So that's df square bracket single quote test passed equals df test passed dot replace. And we just type in the value that we want to replace, which let's say 1.0 will be replaced with no. And we want number 2 to be replaced with yes. So we'll just copy this line, paste it underneath, and replace to with yes. There's a more professional way of doing this so that you don't end up duplicating your code, but you look for this particular use case. And since you're just starting out, let's just do it this way. And then we'll display the data frame again, and you can see the test pass has gone from 2 and 1 to yes and no. Perfect. The next thing is to create the license status column based on a certain set of conditions. So we want to show if a license status is valid or invalid based on a certain set of conditions. So we want it to be valid where someone has passed their test and has less than 12 points. In Victoria, Melbourne, I don't know where it's like in other parts of the world, we have this like demerit point system where every time you like get caught speeding or running a red light, you get points added to your license. And when you accumulate 12 points, your license like gets suspended basically. So we want to show someone has a valid license where they have passed their test and they have less than 12, speeding fine or red light camera points to their name. And in order to do this, we basically use the if function to do it. Ifs are a little bit funny in Pandas data frames. I like to use something called the location function, which achieves the same result as an if, but the concept is a little bit twisted. So let me show you what I mean. So we'll use the location function on our df variable. So it's just df.lock, square bracket, and for now, I just want you to type in rows, comma, columns or cols equals a particular value, which will be valid. So what we're saying here is that for this particular, row and column, we want the value to be valid. And the column that we want to equal valid will be this new column called license status. So we'll put the new column name in here with square brackets and a single quote, and we'll call that license status. And the rows where we want it to equal valid is where the test passes yes, and the points are less than 12. So what we'll type here is the df column where the test passed is equal to yes, and the second condition is where the data frame column points is less than 12. So they're the two conditions, and each condition has to be wrapped inside the regular brackets. So we can select the text, open the bracket, and that'll automatically populate the brackets for us. And for this one there, we'll do the same thing, highlight the text, open bracket, and it'll automatically close it for us too. Let's display this. And I've got an error because I used the double equals there when I should just use a single equals. And you can see license status has been updated to valid, where it passes those conditions. And then to add the invalid, I think the easiest way is just to make everything invalid first. So test passed just equals invalid, and then it'll update everything to valid. I've used the wrong field there, so that should be license status. And I'll just need to run everything again. And there we go. We've got license status, valid, invalid. That's been successfully updated. All right, so the last thing to do is to export the data frame where we've got the valid statuses only and a separate one for invalid statuses. So we'll be doing a bit of filtering here. Again, to filter, we'll use the location function. So let's go df.location, and the rows that we want to get is where the df column license status is equal to valid. And then we'll assign this to a new variable called df_valid. And we'll then export df_valid to a CSV. So that's df_valid .to_CSV, open bracket, and in single quotes, we'll give it a file name of, let's just say valid.csv. And when we run that, it looks like it's been exported. Yep, let's open it up. And that's all our details there, but it's got the index number of our data frame in the file. Let's remove that by adding a parameter called index equals false. And when we run this again, If you get an error, it might be because you've already got valid.csv open. You just need to close it and then run this code again. And yep, cool, the index number is gone. Then what we can do is copy this for invalid. Just update the variable names from valid to invalid, change the condition to invalid, and the file name to invalid. Cool, that's done as well. That's it for this one. I hope you got something out of it. If you have any questions or there's something you want automated, let me know in the comments, or you can just Google it like everyone else. Thanks for watching, and if you want a quick crash course on Python, then check out this video here.